In this video, we'll be learning about composite functions. Now, let's say we're given two generic functions, f of x and g of x. Now, with these two functions, we can make two composite functions. And we write a composite function as f of g of x. In other words, we're replacing the x inside f by the other function, g of x. And at times we'll also write this with a slightly different notation, which means the same thing though, which is the following: f of, a little circle there, g of x. Now, I'm insisting here, both these notations mean exactly the same thing. So we'll be seeing that this is one of the composite functions we can make. Another composite function we can make with our two functions f and g is g of f of x. And again, with our second notation, we could write this g of f of x. Okay, now, let's see how we can actually use this, and we'll use a couple of examples. I'll just write example here. Let's say f of x equals to 2x squared plus x plus 1, and that g of x equals to the square root of x. And we're asked to find the composite function f of g of x. Now, to actually find the expression of f of g of x, what we do is we rewrite the function that we see for f of x, but rather than having f of x, we're going to replace every x we see inside the expression of f of x by g of x. So, looking at f of x here, I can see that I have x squared and an x. So I'm going to rewrite this function, but that x squared and that x will be replaced by g of x squared and g of x. That would be 2 times g of x squared plus g of x plus 1. And now we replace g of x by its expression, which is square root of x. So that leads us to 2 times square root of x squared plus square root of x plus 1. And of course we can go further, since the square root of x squared is just x. This leads us to the final answer, f of g of x equals to 2x plus the square root of x plus 1. And there we go, we've just found the expression for f of g of x. Now, an interesting and important thing to point out here is the fact that in most cases, f of g of x won't equal to g of f of x. And indeed, let's see what g of f of x would be. G of f of x is found by replacing all the x's we see inside g of x, so that's just x under the square root, by the expression of f of x. So that would be the square root of f of x. And now we would just replace f of x by its expression, which remember was 2x squared plus x plus 1, which leads us to the square root of 2x squared plus x plus 1. And that's the composite function g of f of x. So we see there, and actually we'll write this here, that in most cases f of g of x is not equal to g of f of x. So you may want to make a note of that. That's quite important. Now let's look at another example. Let's say, for instance, that we're given f of x equals to 1 over x, the reciprocal function, and g of x equals to 2x minus 4. And again, let's say we're being asked to find the composite function f of g of x. Well, remember, first of all, this is the same thing as writing f of g of x. In other words, this composite function is equal to the expression of f inside which we replace all the x's by g of x. So since f of x is 1 over x, f of g of x will simply equal to 1 over g of x. And that equals to, replacing g of x by 2x minus 4, 1 over 2x minus 4. And there we go. We've just found f of g of x. And once more, let's show that g of f of x isn't the same thing. G of f of x would be found by replacing all the x's we see inside g by f of x. So we can see that g of x is 2x minus 4, so g of f of x will be 2 times f of x minus 4. And now replacing f of x by its expression, that's 2 times 1 over x minus 4, which we can write as 2 over x minus 4. And there you have it. That's how we find composite functions.